when you're multiplying fractions, right, there's a very good way, or a very good reason you'll probably do this one day. And hopefully that day comes sooner than later. And that is when you actually have to paint walls, because hopefully one day you move out and you're going to get your own place, you're going to want to put the color you want. You have to measure the walls and find the square footage, because on each of the cans of paint, it will say what the square footage is. So you need to figure out, well, what's the square footage of all the walls, and add it all up and find out, do I need that little quart, a little small can of paint? Do I need a big gallon can of paint? You know, what size do I need? And you got to keep in mind you use 2 coats. So you have to double whatever you get. And chances are, if you're measuring a wall, it's not going to be exactly 10 feet by 8 feet, which is easy to multiply, like 8 times 10 is 80 square feet. Or square inches, it's going to involve fractions. So you've seen on tape measuring and measure thing, it's not always perfect. It has fractions involved. So it's very useful to be able to multiply fractions. So let's go through this, and I'm going to remind you how to do this, and also going to show you visually what it means, what we're doing. We have something to go off of. So we usually do this step when we're multiplying fractions of converting it to an improper fraction. So we don't want to mix numbers, in other words. We want one number over another. Right? Now, how do you convert this? Okay. So, a long time ago, we had probably like these fraction strips or fraction bars or something like that, and 3 1/4 would be represented some way, probably like this. There's 3, and then there's 1/4. Right? And what we did is we went through and said, well, if you divide each of these into 4, how many fourths do you have altogether? In other words, how many small boxes? So there's 3 rows, right? Each of these have 4, so 3 times 4 is 12. And then you add the one more box over here to make 13. So altogether there's 13 boxes of 1/4 size, which was the same as doing 4 multiplying denominator times this number and adding the top. That's probably how you learned it. But I just want you to remember why this actually works. Why do you multiply the bottom times the whole number and add the top? There's a reason for it, and it's right here visually. Like you're breaking each of those whole numbers into whatever size, so that's when you multiply them. And there's usually one left over, 2 left over. We have to add to it. Same thing here. We could do it with thirds. So if we have 1 and 1/3, how many thirds is that all together? Yeah, you just break this 1 into 3 parts, and now you count them up. 1, 2, 3, it's 4 thirds. That's why 1 and 1/3 is the same as 4 thirds, which is also 3 times 1 plus 1 is 4. And we keep the number on the bottom the same because that's the size we're counting by. We're not going to change that ever. We don't even leave that alone. It's the size of the square, the size of fourths, the size of thirds. Okay. So I'm not going to have you do this for each problem, but I just want you to remember that, well, if you forget how to do that, you can probably draw a picture and figure it out on your own. If you know what it means, as opposed to, well, you just multiply those and you add it, because that's what you do. All right, after this, you can go ahead and do the cross-canceling, if there is any. Like right here, there's a 4 and a 4. So 4 goes into each one of these one time. Make sure you cross it out and you actually put the 1. And give yourself enough space to show this work. I can't tell you, but probably about half the mistakes are not really arithmetic. It's more just you're writing sloppy and you can't read your writing, and then you just write the wrong thing. It's not a good reason you miss a math problem. You know exactly how to do it, but it's just done sloppy, so you get it wrong. All right, so now at this point, multiply the tops together. So we have 13 times 1 over 1 times 3 is 3. And the nice thing is, the cross-canceling is the same as reducing. So if you reduced, if you cross-cancel, you have reduced. You don't have to look at 13 over 3 and wonder, well, can I reduce that more? It's already done from the cross-canceling. So that's a long explanation for multiplying fractions. There's a good reason to do it. If this was actually like paint and things like that, we would divide those and actually do 13 divided by 3, get 4.33 or 4 1/3, and we can figure out what size can of paint we need to get. Right? So very practical reason for doing that. Okay, so let's look at two more. We're going to do number 3 and question about that. Okay.
Oh, yeah. So for the answer, we don't have to type it.
Yeah, if we're not doing a word problem, like we're actually doing a word problem that said, you know, what size can paint do you get? You'd have to actually figure out this as a mixed number or a decimal. But if we're not doing a word problem, just leave it as an improper reduced fraction. Okay. So, like, if this was a word problem, this is like money. You wouldn't say, oh, I owe $13 over $3. You would say, I'm $4.33 and convert it. But without that, we can just leave it as an improper fraction. Okay, so let's try it one more time. Nice thing here is it's already improper. Already, we don't have to do anything to that. Just have to convert the first one. So how many parts of 5 or fifths do we have with 1 and 1/5? 6 fifths altogether, right? We get 5 from this one plus 1 more. 5 times 1 is 5 plus 1 is 6. Anything cross cancel? Nope. So sometimes it does, sometimes it doesn't. And since nothing cross cancels, nothing will reduce after I multiply. So I know this is 18 over 25. Lots of circle that. Why don't you guys go ahead and try number 5. Convert both of those to improper fractions. Check with your neighbor or someone around you. You don't have one. See if you got the same fraction. So I saw a lot of people get 4 times 3 is 12. Plus 3 is 15 fourths. And we have same thing as number 1. 3 times 1 plus 1, 4/3. And let's cross cancel. So, you guys ready to cross cancel? So, cross cancel the 4's, and we get 1 and 1. 4 goes into 1, 4 one time, 4 goes into 4 one time. And then 3 goes into 3 one time. 3 goes into 15 5 times. So multiply what we have left. We have 5 times 1. And then 1 times 1. But we usually don't write your final answer as over 1. So you can just write it as just 5. Like that. And then that one. Otherwise, we won't. Okay, go ahead and try a few more, then check with a partner, see if you're on the same track. If not, just raise your hand. We'll come around and help you out. Okay, go ahead and flip it over. Check out your vision. Ready?
No, that one you keep.
Okay.
That one you didn't want to know.
Right after. Okay. Now, just much like the front where I was talking about the buying cans of paint, I want to review dividing. And there's this rule that you guys know, probably like keep, change, keep, flip, or some rule that says, well, you keep the first fraction the same, but then you change the division to multiplication, and then you flip the second fraction. But why? Why do we do that? How come you don't flip the first one? We can't just make up rules and say, oh, it's got a nice little sound to it, so we're going to go with that. So I want to review real fast why we do that. Think about if you have $10 and you're dividing it among 2 people. How much does each person get? $5. Okay. Now, can't you ask that same question and say, well, I have $10. How much does each person get? How much? Yeah, and how do you figure that out? Take half of it. Each person gets half. So dividing by 2 over 1 is the same thing as taking half, or multiplying by 1 over 2. And that's the reason why we do this. The first number doesn't change. We're still talking about $10 on each one of these. But logically, not mathematically, but logically, dividing by 2 is the same as taking half of something. So that's why we do that. It just makes logical sense because you get the same answer either way. You both get $5. So you can ask any division problem can be converted to a multiplication problem. Any multiplication problem can be converted to a division problem. Okay? It's just two ways of looking at the same thing. Now, it's easier as a multiplication problem because you can cross cancel like we did on the front. And that's why we always convert division to multiplication and not really multiplication to division. Not like on the front we're flipping the second fraction and doing that because cross canceling doesn't work that way. So we like the cross canceling, that's why we convert to multiplication. And once you do that, it's basically like the front side. So we just have to convert 6 times 1 plus 5, 11 over 6, do the equal signs. We got 4 over 7. Does anything cross cancel? 11 and 7, no. 6 and 4, yeah, 2 goes into both of these. 2 goes into 4 2 times. 2 goes into 6 3 times. And we have 11 times 2 and 3 times 7. And we don't have to worry about reducing because we cross cancel with the same ones. So please keep in mind, at least walk away with your totally understanding that, yeah, if I divide something by 2, that's the same as taking half of it. It means the same thing, and that's why we choose that second fraction. All right, do just a few more. Let's work some more. Let's actually do 15 because it's actually what I was just talking about. So dividing by 2, dividing anything by 2 is the same as finding half. Right? Dividing by 2 and multiplying it by half is the same thing. If you need to, you can make it 2 over 1 and then it's each flip. But hopefully we get beyond that and just say, well, this makes sense. Dividing it by 2 is the same as taking half of something. So the first fraction, 2 times 6 is 12. 12 plus 1. That equal sign there. Now, if this is super easy and you kind of remember all this, focus on your format. Get those equal signs there, get them lined up. Focus on how neat you're writing it. Make sure it's not small and tiny that nobody can see it. You can always focus on your penmanship or organization. That's worthwhile. Are there any other on the back that you'd like me to go over? Or you guys need to keep going? Maybe 14, since 14 has a mixed number, has a second number. That go fast. So 14, look at 14, we'll have 2 times, 2 divided by 2 times 1 plus 1 is 3 over 2. And now flip the second fraction. 2 times 2 over 3. So you see here how I had to convert it to improper fraction, then flip it. Don't flip it here to 2 over 1. You have to convert it first. And if you need to, you can make that 2 over 1. And then our final answer will be 2 times 2 over 1 times 3. And there's your final answer. Go ahead and do a few and check with your neighbor. And whatever you don't finish, we'll finish up at the beginning of class tomorrow. With your warm-up.